Okay, today we are going over 11.4 Arithmetic Series. So let's take a look at this sequence right here. We have the sequence 1, 2, 3, all the way up to 100, 98, 99, 100. Okay, and let's take a look at what we notice here. We first want to look to see if it's an arithmetic, geometric, or neither of these type of sequence. So if we notice here, every time to get to the next term, we are adding 1. So since we're adding the same number, we call this number the common difference, which is D. D is the common difference. And since we're adding, then we know it's a type of arithmetic sequence, which is why we're going over arithmetic series today. Okay, so let's answer these questions that they have here. It says add the first and the last terms of the sequence. So the first plus the last term. We're going to add those up. Okay, that's 1 plus 100 is 101. So that's 101. We're going to now add the second and the second to last term. Okay, that's 2 plus 99. 2 plus 99, well, that is 101 also. Okay, continue adding terms until you get to the middle, or we can just see what pattern we notice. Let's do the next one. We'll add 3 plus 98. 3 plus 98, that is 101. So we should start to see a pattern here. And we should notice that every time we're getting 101. So what we want to notice is we can write down that the pattern is when we keep adding the numbers all the way till when we get to the middle, which would be 50 plus 51, we'd get 101. Okay, so we want to look at using our answers here to find the sum of the terms of all of these numbers. From all of the numbers from 1 to 100, what would the sum be if we add all of them up? So we should be able to see that every time I add the first number, 1, and the last number, which was 100, if I add those up, I keep getting 101. And notice that these are coming in pairs. So since they're coming in pairs, we want to look to see how many pairs would I have in the numbers 1 all the way through to 100. And actually what you're doing when you're finding a pair is you're taking however many numbers you have, which in this case there's 100 numbers here, and you're dividing that by 2 to get the amount of pairs you have. So that's actually 50 times 101. And that's how you would find out what the sum is for all of the digits from 100 to 101, instead of going through and actually adding them all up. So when you multiply this out, 50 times 101, you get 5,050. And that is the sum of all the digits from 1 to 100. So what we did was we looked at a pattern here and we came up with this instead of actually adding 1 plus 2 plus 3. That would be really tedious. So we noticed that it was an arithmetic sequence. We found a pattern. They kept adding up to 101, and then we used this pattern here. So what we're looking at here is this is actually going to get us to our equation for our arithmetic series. So if you notice, this 100 here was n, which was the number of terms that we're adding up. We had 100 terms here. We're always going to divide that by 2. Then this first number here, or this 1, that was our first term. And we use a sub 1 to represent your first term. This 100 is your last term. So whatever the last term is, that's going to be a sub n. And this is how you find your arithmetic series. So the next slide is going over just that. So an arithmetic series is a series whose terms form an arithmetic sequence. So you're going to actually take the sequence and add up all of the terms in the sequence. So notice what it has here. It says it's the sum of a finite arithmetic series. Finite means that there's an end, that the sequence is going to stop. So this is only for a finite arithmetic series, meaning you're adding up a specific amount of numbers. Okay, if it was infinite, meaning it kept going on and on forever, we wouldn't be able to find the sum for an arithmetic series. So we just wrote down this formula. S sub n is representing the sum. So S for sum. Okay, n is being represented as however many terms, the nth term, or n is the number of terms that we're adding up, n over 2. So in the previous case, we had 100 terms, so your n was 100. And then we're going to take our first term, a sub n, a sub 1, and add that to your last term, which is a sub n. Okay, so a series is the expression for the sum of the terms of a sequence. So if we notice here, a finite sequence is just listing all of the terms, 6, 9, 12, 15, 18. And a finite series is adding these numbers up. So now you're actually adding them up. Okay? So if we look for at an infinite sequence is telling us that it's going to keep going on and on forever. And an infinite series will also keep going on and on forever, which means it's not going to be approaching a number, and we cannot find these for arithmetic series if it's infinite. Only for finite. You can only find a finite arithmetic series. So let's take a look at this. It says writing and evaluating a series. We're going to use the finite sequence, where it just lists the numbers. We're going to write the related series. So the related series is just actually writing all of these down, but adding them. 2 plus 11 plus 20 plus 29 plus 38 plus 47. Okay? This is the series, the related series, and then you can evaluate it. So this one doesn't have that many terms in it, so if you actually just went and added all of them, you can do that, or you can use the equation that we just learned, which I find to be easier. So I'm going to count how many numbers I have here. I have 1, 2, 3, 4, 5, 6 numbers here. 6 over 2. My first term, a sub 1, the first term is a 2 here. And my last term, a sub n, is 47. So evaluating this, I have 6 over 2 is 3, times 2 plus 47 is 49, and 3 times 49 is 147. And that is the series for all of these numbers. Okay, we're now going to learn the summation symbol. This is actually the Greek letter sigma, and that's going to be, we're going to use that to write a series. So here's what it's going to look like, and then we'll actually find some of them. So you're going to have limits here. You're going to have a lower limit is going to be the first digit that you're talking about. If you want to start from the first term, then n will be 1. And then you have the upper limit, the greatest value of n. If you're going up to the third term, then it'd be a sub 3. And then right here, so this means the summation. This is the summation symbol, or the sigma symbol in the Greek alphabet. And then you have your explicit formula. Okay? So we look at this and be able to find what the sum is. So we're just going to practice writing the summation notation. So to do that, we're going to look here and say, okay, we first need to find the explicit formula. So we need to know if it's arithmetic or not. So we want to make sure that we're adding the same number every time, which we are. We're adding 3 every time. So we can use our explicit formula, our arithmetic explicit formula, which is a sub 1 plus d times n minus 1. Okay, so we're going to look here and we're going to notice that we can write this formula. A sub n is equal to, our first term here is a 3, right? That's the first term. Our common difference d, we're adding 3, so your common difference is a 3, n minus 1. Distributing in your common difference of 3, we get 3 plus 3n minus 3. So therefore, our explicit formula is 3n. Okay, so now we can actually find that our lower limit, we're going from the first term all the way up to, it says, for the first 33 terms. So the upper limit will be 33. So to write this out, we're going to write it as our summation notation, which is the Greek letter sigma, is going to be going from n equals 1 to 33 terms, and our explicit formula, which is, we just found, is 3n. And this is summation notation. It doesn't actually ask us to find the series, which is the sum, but if it did, we would be able to evaluate that with our previous formula that we learned. Okay, so moving on here, again, we're just writing the summation notation. So we want to make sure, again, that this is a arithmetic series, and again it is, we're adding 5 to get to the next term. So we need to write our explicit formula, a1 plus d times n minus 1. Our first term is a 3. Our common difference is a 5. We're going to distribute in our 5 here, our common difference, 3 plus 5n minus 5. Combining our like terms, we get 5n minus 2. That's our explicit formula. We want to go up to the 9th term. So we have our summation notation is going from, our lower limit is 1, our upper limit is 9, and our explicit formula here is a 5n minus 2. And that's summation notation. Okay, so now we're going to actually use summation notation to find the sum of the series. So the first thing that you're going to have to do is find the number of terms in the series. So how many numbers am I actually adding up? So since we're going from our lower limit of our first term 1 all the way up to our upper limit of 3, that means that we have the values of a sub 1. It's telling us to add up the first, the second, and the third terms. Okay, so therefore we have 3 terms, and that means that n is equal to 3. Okay, so then that means that we're going to find the first and the last term, because we need to keep in mind what our equation is, which is n over 2 times our first term plus our last term. So n we already know is 3. Now I'm going to find the first term. So you'll find the first term by plugging in 1 into your explicit formula. It's giving you the explicit formula. So a sub 1 is going to be plugging in here. So we have a sub 1 is going to be 5 times 1 plus 1. Okay, so then we're going to get 5 plus 1, which is a 6. So a sub 1 is 6. Our last term here is, we're going to plug in for 3. So a sub 3, we're going to plug in 3 for your n. 5 times 3 is 15, plus 1 is 16. So your last term, which is a sub 3, is 16. And then we're going to evaluate the series. So we can evaluate the series now with all the information we know. So we're going to take our s sub 3, because we're adding up 3 numbers. We're going to do n, which is 3, over 2 always. Take our first term, which is 6, plus our last term, which is 16. and add these up. So we have 3 over 2 times, we're adding these up, 6 plus 16. Okay, so 16 plus 4 is 20, another 2 is 22. And then we can cancel this out here. 22 over 2 will be 11. And then therefore we get our sum to be 33. 3 times 11, or 33. And that's how we found the sum of when it's written in summation notation. Okay, trying a couple more of those problems. This one's going from 1 to 10. So we know that we first want to find the number of terms. So n is going to be, if we're going from the first term all the way to the 10th term, we're adding up 10 terms then. We need to find the first term. Our first term will be a sub 1, and then we'll plug in 1 for n. 1 minus 3 is a negative 2. Our last term is going to be a sub 10. A sub 10 is going to be 10 minus 3 is 7. So using our summation notation, s sub 10, so we're adding 10 numbers up, we're going to use our equation here, our first term plus our last term, and then plug in. So we have a 10 over 2, our first term is negative 2, our last term is 7, 7 minus 2 is a 5, and 10 over 2 is a 5, and 5 times 5 is 25. So our sum of these first 10 digits, 10 terms of this sequence is 25. Okay, and then finally here, we could do the same thing. N is going to be equal to, we're going from the first term to the fourth term, so n is 4. We'll find our first term by plugging in 1. Half times 1 plus 1 is half, plus 1 is 1.5. Okay, and our last term, a sub 4, is half times 4 plus 1. Half of 4 is 2, plus 1 is a 3. So we have the number of terms. Our first term is 1.5. Our last term is 3. And then we're going to plug that into our equation. Our equation is, which we just learned, S sub n is equal to n over 2, the first term plus the last term, and then we're going to plug that in. So we get S sub 4, because we're adding 4 of the digits up, 4 over 2. Our first term here is 1.5, plus our last term here is a 3. 4 over 2 is a 2. 3 plus 1.5 is 4.5. Doubling 4.5, we get 9. So therefore, we get S sub 4 is equal to 9. And that's the sum of the first 4 digits in that series. And that covers 11.4 arithmetic series. Thanks for listening.